we have been adding and subtracting now, and so it comes to multiplication. So the rules are fairly simple, right? To multiply a fraction by another fraction, we basically just multiply straight across, top by top, bottom by bottom. It's probably the easiest operation among fractions. You don't have to bring to the common denominator and all that stuff. But I kind of want to argue for it. So let's say we want to multiply a fraction by a whole number. Let's say something like 3 times 2 over 5. Well, you know, multiplication could be defined as repeated addition. Like 3 times 4 is 4 plus 4 plus 4. And so if we want to go with this, and we do, that means that we kind of have no option but to interpret this multiplication as repeated addition. But that fits with our rule because we can always think of a whole number as an integer. All we got to do is just what I call growing a 1, right? So it sort of fits. But multiplying a fraction by a fraction, first of all, let's just go back to the basic definition. What is 3/5 of 40?
24.
Yes, 24, because what I told you is divide by 5, and then when you, that's 8, and when you're done, multiply by 3, that's 3 times 8, that's 24. But now I kind of want to observe that that's the same as 40 times 3 over 5. With our new rule, again, when you multiply, sometimes cancellation before multiplication keeps your numbers smaller. So I would cancel out here. That is your 8. 8 times 3 is 24. So basically, we could interpret multiplication as part of something. And it is. It is. So taking 3/5 of something is the same as multiplying by something. Multiplying by 3 over 5, sorry. So taking 3/5 of something is the same as multiplying by 3 over 5. If that's the case, then I just want to draw a picture for fraction multiplication. Let's say something easy, like 3 over 4 times 2 over 3. If we perform the rule, we're going to get 6 over 12, or cancellation, 2 over 4. Basically, we're going to get 1/2, right? One way or the other, we're going to get 1/2. But now I want to show you that this is the same as 3/4 of 2/3. So, okay, so here is 1, and we're going to chop it off into 4 equal parts, and we're going to take 3 parts. That is the picture for 3 over 4, right? So this slightly shaded area expresses 3/4 if this whole thing is 1. And now we want to take 2/3 of that. So we're going to take, just think of this as, I shouldn't have drawn these lines dark because now imagine that that's not there. So we're going to split it up into 3 equal parts and take 2 such parts. We're going to take 2/3 of this. So this here is 2/3 of 3/4, right? Here is 3/4. We split it into 3 equal parts and took 2. But now if we continue, we can see that this little rectangle here can also be expressed as what over what? How many little rectangles did we create? We have 12 of them, right? 4 plus 4 plus 4, and we have 6 of them. So that is sort of the argument for fraction multiplication. It's a part of a part. That's what it means. The other thing is that all the rules of sign numbers remain the same. So positive times positive is positive, negative times negative is also positive. So those rules remain the same. Order of operations remains the same. And so I kind of need to warn you about something, that we're not going to go over order of operations with fraction again, because you know fractions, you know order of operations, you put it together. But there might be little glitches. For example, sometimes we put fractions in parentheses when reasonable numbers, we don't. For example, here is an example. You see, I already did the parentheses there. If we have just a number like 3 to the 4th power, we don't need a parenthesis. But I think you can figure out why we need the parentheses. Like, what's the danger here? Well, we don't want to read this as 2 to the 4th power, and when you're done, divide by 3, right? Positioning is not good enough, so we need a parenthesis to say, sort of say, hey, exponentiate the whole thing. And by the way, exponentiating is repeated multiplication, so that would be 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3, which should be 16 over 80. You know, I'm always very outspoken when I think that something in the American mathematics curriculum is not that good. This one is sweet. And I should mention it if I mention the other side of that coin. So this one is really, really good. If you're old, you might have heard about unit multipliers. And if you're younger, you might have heard the same thing relabeled as conversion factors. I kind of like both names. Multiplier and factor is the same thing. That's something that participates in a multiplication, right? But unit is just a fancy word for one. So for example, the unit square is a square with sides 1. A unit circle is a circle with radius 1. So unit is sort of just a fancy word for one. And conversion is the act of converting things. So I'm going to show you an example with something that you really understand and have instinct for. Therefore, you don't need the stuff that I'm showing to you, but I'm hoping it will be easier for you to understand. Here is a fact: 60 minutes equals to 1 hour, right? And so out of this little fact, we can make 2 fractions, so to speak. 60 minutes divided by 1 hour, and 1 hour over 60 minutes. These are 2 fractions with both of them has a value of 1, because we divide a quantity by itself. Okay, it's expressed differently, but it's the same thing. 60 minutes divided by 1 hour should be 1, right? Hence the word unit in unit multiplier. These are fractions of value 1. And what they're going to do, surprise, surprise, they're going to help us convert from one unit to another unit by exploiting cancellation in fractions. So suppose I have something like 420, it's going to be easy, minutes, and I want to convert it to hours. Well, this is going to be about fractions. So if what we're starting with is not a fraction, let's fix that first. All right, now it's a fraction. And so basically, if we want to convert, convert 4,200 minutes to hours. I know you can do it in your head. We're going to multiply this by a fraction with value 1. Value 1, that's a safe multiplier. We're not going to change the value. But what we're going to do is we're going to cancel out what we want to get rid of and bring in what we want. So because we want to get rid of the minutes, we're going to choose minute here. And that determines the rest of this conversion. Basically, we're going to use this one. This is the one we use to get rid of minute, bring in hours. This is the one that we use in the other direction. Get rid of hour, bring in minutes. 60 minutes is 1 hour. And there it is. And so we got 4,200 times 1 hour divided by 1 times 60. So that's, I think it's 70 hours. Hey, suppose we want to keep going. And it's like, that's a lot of hours. Maybe we should convert it to days. The thing about it, you can just pile up one unit multiplier after the other. Yeah, I'll just do it. So we want to get rid of the hour. So we want to cancel it out, and we want to bring in the day. And we know that 1 day is 24 hours, and hour is canceled out, and we're left with day. And I guess one thing that we can do is just simplify this fraction as much as we can, and maybe express it as mixed number, like 3.5 days, something like this. I think it's not going to be 3, but almost. 35 over 12. See, it's almost 3. If this 35 would be 36, it would be 3 days. So it's almost 3 days. That's 2 and 11, 2 days, 11 hours. So one advantage of these unit multipliers that you can line them up. Let's see if we could do, all right, let's do, this is 1 million centimeters to miles. All right. So if we start with 1 million centimeter, well, there is a way to go from centimeter to inch. 1 inch is 2.54 centimeters. So about 2.5 centimeters is 1 inch. So we can get rid of the centimeters and bring in the inch. Cancel, cancel. Now we're going to be in inches, and 1 inch is 2.54 centimeters. Okay. Then now we're in inches, we can go into feet, right? We can get rid of the inches, bring in the feet. And what numbers can I write into this fraction?
12 inches.
1 feet is 12 inches. And then 1 mile is, I always get this one wrong. It's 5,820 or 5,280 feet. We're gonna live with it. So we're gonna get rid of the feet. We're gonna bring in the mile. And so now we piled up three unit multipliers. And so what we have is 1 million on the top, miles on the top, and then 1 times 2.54 times 12 times 5,820, no unit on the bottom. So we're gonna get the answer in miles. I guess this is as good time as any for decimals. So 1 million divided by 2.54 equals divided by 12 equals divided by 5,820. So it's 5.63 miles. All right. One more example. Because until now, it was always at the same place. It was always in the denominator. So I don't want you to think that it's always in the, you just divide, because then we wouldn't need unit multipliers or conversion factors. Let's take 70 miles per hour and convert it to meter per second. Meter per second is the official, the scientific international units. It's a very logical, but that's the one that you're going to use in physics. This is the one that we are used to. 1 mile is 1.609. We're going to round up to 61 kilometers. All right, the rest we know. So 70, well, we grew over 70 over 1 miles per hour. We can really emphasize that we're dealing with a fraction. So we can get rid of the mass and bring in kilometers. Basically, we can say that 1 mile is 1.61 kilometers. And now it's kilometer per hour, which is what European cars will show you. Okay, so do you know how many meters a kilometer? How many bytes is a kilobyte? All right, the word kilo means 1,000. So a kilometer is 1,000 meters. A kilogram is 1,000 grams. A kilobyte is actually, well, we kind of want to say 1,000, but with little electric currents, yes or no, left or right, up or down, we can only double up things. So if you take 2 powers and you double up to 1,000, it's 1,024. But kilo means 1,000. A kiloliter is 1,000 liters. So 1 kilometer is 1,000 meters. And now we can start working on the hour. Now the hour is downstairs. So to cancel it out, we put it upstairs and let's say minute. And we know that 1 hour is 60 minutes. And now we're in minutes and 1 minute is 60 seconds. So here we are. This is much harder without conversion factors. What do we have upstairs? We have 70 times 1.61 times 1,000 divided by 60 times 60. And we are in meter per second. 31.3. 31.30555 meter per second. Okay, so this is really very useful in case of complicated conversions. Let's do one more. You may know that 1 yard is 3 feet. What about 1 square yard? How many square feet it is, you think? Just guess. So a square yard, as I'm trying to beat it into you, is literally yard times yard, like x squared is x times x. So we're going to have to use 2 unit multipliers, 1 for each. And so 3 feet equals to 1 yard. 1 is gone. And then we'll repeat 3 feet equals 1 yard. So we get 9 square feet. Now, a square feet is a 1 feet by 1 feet squares area. And if this is a yard, then here is 1 feet, 1 feet, 1 feet. This line here, it expresses that 1 yard is 3 feet. But 1 square yard is not 3, but 9 square feet. You see that? That's the argument there. But the units just work. They're just sweet that way. Mixed numbers. So you have options, but especially if the numbers are not too nice, I would just say right away, get rid of the mixed number, work with improper fractions. For example, 3 1/3 times 2 1/2. Okay, let me show you something like 5 times 3 1/3. The problem is that 3 1/3 is short for 3 plus 1/3. And the distributive law says that if you have a sum that you want to multiply by something, you have to distribute that. So the distributive law tells you that if you have B plus C and you want to take that sum and multiply it by A, now usually we would just use order of operations, right? Add first B and C, and then, but suppose we don't know B and C, it's like X plus 2, then our only other option is to distribute. So this would be 5 times 3 plus 5 times 1/3, which is 15 plus 5 over 3, which is like, even for a mixed number is pretty bad, right? Because it's more like 16 2/3, because we can take away 3/3 from this part and jam it with those guys. I think you might be better off just to say 5 times 3 1/3 is 5 over 1 times, and then go improper. 3 1/3 is 10 over 3, right? So that's 50 over 3. And in case I'm still your teacher, you can stop right there. But actually, it is the same as 16 2/3. And this one would be even more terrible. Yeah, I don't even want to go into details how terrible it would be, but it would be pretty bad. So just go improper immediately. This is 5 over 2, right? So we have, you see there is a little cancellation here between 10 and 2. So this is gone, this is 5, and so we get 25 over 3. That would be a pretty difficult thing to do with mixed numbers. When it comes to multiplication, most of the time mixed numbers are a problem. First thing you're going to have to do is get rid of them and work with improper fractions. So 2 numbers are reciprocals of each other if their product is 1. That's the grown-up definition. You might think of reciprocal as the flip-flop, and that makes sense because if you take 2 over 3 and you flip-flop it, you get 3 over 2. And if you multiply the 2, then it's very clear that we're going to have the same thing upstairs and downstairs, which is 1, right? But the grown-up definition is a number and its reciprocal always multiplied with 1. And it's kind of a pair. The reciprocal of 2/3 is 3 over 2. The reciprocal of 3 over 2 is 2/3. Very much like 5 and -5 are opposites. Sometimes when you don't have a fraction and you want to flip-flop, you just have to grow a 1. So the reciprocal of 4 would be just flip 4 over 1. So it's 1 over 4. And then indeed, 4 times 1 over 4, 4 over 4 is 1. And that's why if you don't know what you're dealing with, but you want to express the reciprocal, that's why we say the reciprocal of x. Now, x could be a fraction like 5 over 3 or 2 over 7, or it could be an integer like 7. We don't know. But the way we express it is we're going to say grow of 1 and flip is 1 over x. And indeed, x times 1 over x is grow of 1, x over x equals 2. The only number that has no reciprocal is 0, because you cannot multiply 0 by anything to get 1, because anything times 0 is going to be 0 for you, right? 0 is the only number that has no reciprocal.